Okay, so we're ready for lesson 2.5. Now, I'll just say this lesson it's going to seem a lot like algebra. In fact, we're going to do several algebra problems together. But the focus is not so much on the algebra, but rather on the justification. So what we're going to be asked to do in this lesson, we're going to be asked to justify the steps of algebra. And so we're going to learn about several properties of algebra, and so in many cases this will be review, at least from the algebra standpoint, but again, we're going to be in the habit of justifying everything. So let's get started and take a look. So reason using properties from algebra. I'm going to do part 1 and part 2 on the Camtasia video right now, but probably in class I'll divide this over a 2-day period. In any event, let's get going. So the objective will be for students to be able to solve an equation and justify each step along the way. Well, so how do you solve an equation? Well, that part I think is the easy part, but anyhow, from algebra we have a bunch of properties, and I want you to notice that these are properties of equality, and I want to just take a moment to talk about that. Like for example, when we have these properties here, the addition property, the subtraction property, the multiplication property, and the division property, the only reason why we can do these is because we start out with an equal sign right there, okay? And that's the only reason why we can do this. And so anyhow, all these properties are fairly obvious, and we do them when we're solving equations all the time. It's like when we have 2x like minus 5 equal to 7, what we want to start out by doing is adding 5 to both sides of the equal sign. And the reason we can do this step is the addition property of equality. Okay, so we're going to have to be in the habit of justifying each step along the way. Now, I want you to realize that these are rules for equality. Now, there's other types of equations that happen, and there's certain rules for inequalities. So let me just go over one real quick. If you had, let me just show you a quick example. Like if you have negative 2x is greater than, let's say 10. One of the rules for inequalities is that when you divide through by a negative number, you have to flip the sign of the inequality. So the negative 2 would cancel here, and then we'd have x here, but then the arrow would flip this way, and then we'd have negative 5. So that's a property of inequalities, okay? So I want you to keep in mind that all of these properties are properties of equality. It basically means, once again, that there has to be an equal sign involved in order for you to do these properties. So with that thought in mind, let's get started on some examples. Oh, there's one other one that you probably haven't seen or haven't talked about too much, and that's the substitution property. In geometry class, we'll actually use this one a lot. Basically what it says, if A is equal to B, then you can replace B like anywhere you wanted with A, because they're equal. Like for example, if this were the case, we could put an A right there, for example, change that to an A if they're equal, and that's called substitution property. Kind of like substituting in sports. Same idea. Substitute a goalie with another goalie. Hopefully they're equal. Okay, so what happens is we're going to be using these ideas in geometry, and we start off with algebra because you're a little bit more familiar with algebra. Excuse me. So you're a little bit more familiar with algebra, and so we're going to try and get you used to these ideas of justifying with algebra, and then we'll then work on geometry ideas and teach you to justify the ideas in geometry. So we start off with something simple and gradually move to something more difficult. So let's practice this idea of writing a justification for each step, or a reason. So here's a baby algebra equation from algebra class. Hopefully you could all solve this on your own. The focus here is going to be writing a reason. So typically what I'm going to do is I'm going to put a little dividing line here, and I'm going to put my reasons over here, and reasons, okay? And sometimes we draw a little bar going across the top here, and I'll try to draw a straight line here. Yeah, that's not too bad. And over here what we have are statements, okay? Okay, so anyhow, what I'd like to do to solve this equation is I'd like to move these three x's over here, because they're negative, and move them to the opposite side, to the left side. And I can do that by adding. You see, what I'd do is this: I'd add 3x here, and I'd add 3x over here. Okay, and then we'd just draw a line across, and what we'd get, this part would simplify, and we get 20 right here, and we get 5x plus 5 right here, and then we have equals. Okay, so now what we need to do is write the reason for this step right here. And as we saw on the previous page, the reason that we can do this is the addition property. The addition property of equality says, hey, you could add the same number on both sides of an equal sign. There's our equal sign right there. So we're allowed to do this. It's called the addition property of equality. Okay, and so we just proceed and solve these equations like we normally would, and as we go along the way, we want to go ahead and write the step that we're going to do, the reason that we can do that step. So I think the next thing we do is subtract 5. We want to move the 5 over to this side of the equal sign. Well, there's our equal sign, so we're allowed to do this. So we subtract 5 here, subtract 5 here, and that gives us 5x is equal to 15, right? Well, the reason that we can do this step right here is, first of all, because there's an equal sign involved. And so what we did is subtracted the same number from both sides of the equal sign, and we're allowed to do that because of the subtraction property. Property of equality. Okay, so all we're going to do is just keep on going, and we're going to write the reason for each step along the way. So what should we do next? I think the next thing we do is divide by 5. Divide this side by 5. Okay, so the 5's cancel, and so we get x is equal to 3. Okay, so we've solved this equation, but what we need to do is write down the step for this one right here. The reason that we're allowed to divide by 5 is, first of all, we have an equal sign involved. So this is called the, how about if I start abbreviating? That's the division property of equality. Okay, so it's okay to abbreviate for your homework. I will understand what you mean if you want to use these symbols instead. Like you can use the subtraction property, addition property of equality, and then that way I'll understand what you're doing, okay? Just for my class, that's okay. Now if you're taking any state tests or whatever, I'd write out every word so that they understand what you're doing. But for my class, it will be okay to use the symbols instead. Okay, so we did a problem together. Let's take a look. What's next? Well, there. Alright, this is a little bit more steps involved here. Okay, so let me just mention a few things about all of these steps here. Now, usually when a problem is given to us, we could write down the reason for that is that it was given. So that happens quite a bit. So we did that one. And these simplification ones, we don't really need those in here. I mean, that's just like duh. So we did the addition property first by adding the 3x's, then we subtracted the 5, so that's subtraction property. And then what we did after that is we did the division property right there. So, and then the subtraction property right there. So as you can see, this stuff's not terribly hard. It's just that you just need to be in the habit of writing down the reason now for each step that you do in the problem. So let's try another one. I know you're excited about this and you just hardly could contain your joy for this, but not terribly hard, but we got to write down each step. So what do we want to do first? How about if we move these 4x's because they're negative, we'll move them over to the opposite side. And since we have an equal sign right here in the middle, we're allowed to do this. So I'm going to start out by adding 4x. And I'm going to add 4x over here. And that gives me 8 over here. Oh, let's see, this gives me 7x. Okay, and these of course simplify, they're not there anymore. And so I get this number over here, negative 34. Okay, but I have to write down the step here, so I'm going to put a little line here. Like I said, over here we're going to put the reasons. So the reason for that first step is addition property of, now do you mind if I abbreviate again? I'm going to write the equal sign, addition property of equals. Does that make sense? Alright, that's our own way of simplifying things. We're not to write out the dumb word every single time. Okay, so now the next one we want to do is move this 8, right? So I think what we'd do here, I think what I'd do is subtract 8. And I would subtract 8 over here, right? So, and that would give me what? 7x over here is equal to negative. Let's see, two negatives add together give me a bigger negative. So that's negative 44. Yeah, I think negative 44. Alright. So the reason that we're allowed to do this one, well, let's see, we subtracted both sides because we have an equal sign. So this one's called subtraction property of equality. We'll use this symbol equals to abbreviate, okay? Subtraction property of equality. Alright? And I think the final step is just simply divide by 7. Divide by 7 here. Divide by 7 here. And I get x is equal to negative 44/7. Alright, so this step we could simply say is the division property of equality. Alright, so don't make these problems any harder than they are. All you need to do is, the only thing that's new as far as you're concerned is these steps over here. You have to get in the habit of writing down these reasons. We're going to be in the habit of justifying things in mathematics. That's one of the powerful ideas we learn in geometry. And we do this because, well, anytime you solve a problem, you want to be able to justify your answers. It's like you go to the doctor and they say, oh, well, we have to amputate your arm. Most people say, oh, really? Well, how come? And so then the doctor has to explain why they have to amputate your arm. Normally you're not going to just say, well, because I said so. The doctor has to justify things. He has to say things like, well, you have a horrible disease that's none of the antibiotics can kill this bacteria. So you have like a flesh-eating bacteria, and it's in your arm severely, and so we're going to have to amputate your arm. So okay, so that's the justification. So we do this all the time in real life, and it's very necessary. And this is what it looks like in mathematics. You're going to be asked to justify your work on these problems here. And so get used to it. And I know it'll be a struggle at first. You're not used to doing this, and it'll be a little bit trickier when we do it in geometry. So we want to start getting used to the ideas with these easy algebra problems. Well, let's move on. Some other properties of algebra that you should have learned is the distributive property. Now, I'm kind of surprised by how many people don't know this, but the distributive property is basically a multiplication property where there's a little dot here, and the number on the outside basically multiplies by every number on the inside. Okay, so if you do a times b, you get ab, and then you have this plus sign after that. And then you take this number and multiply by the other number that's inside of here, and you get AC. So, distributive property. So, when we see this step in an algebraic problem, when it comes to the reason over here on the right side, we're going to say, oh, well, the reason that we can do this step right here is the distributive property. Now, this one you don't have to do. Notice there's no of equality on this one. This one you can actually do even if there was no equality sign. Does that make sense? So this one you can just say is the distributive property. You don't need to add on of equality. Okay, let's try another problem. Alright, so here's another problem, and once again what we're going to do is write our reasons. And so on the right side we're going to write the reasons. So this problem was given to us, so normally what we'd do is we'd write down, oh, well, this step right here we'd say, oh, this problem was given to us. Okay, so we're going to say it was given. Alright, but the next step, what I would do is I would use the distributive property right here. I would multiply these two numbers by this -4, and so the -4 times 11x, that gives me negative 44x, and -4 times 2 is -8, and then I have this equal sign 80. Well, the reason that we could do this step, actually it started right there. Okay, it's called the distributive property. Distributive. Okay, so like I said, on this one you don't need the distributive property of equality. As you notice, we didn't do it to both sides of an equal sign. We just did it on the left side only. So this is called the distributive property. From here though, what do we want to do? I think if we're solving for x, we want to get rid of this 8. And since that's a negative 8, we want to do the inverse operation, which is the opposite of subtraction. So we want to add 8. So we're going to add 8 here and add 8 over here. And the reason why we can do this is because there's an equal sign. And remember, this property says what you do to one side of an equal sign, you have to do to the other side as equal sign. So this is a property of equality. And so over here we're going to have negative 44x. And then over here we're going to have 88. And when we write down the reason, we're going to say the addition property. Okay, the addition property of equality. Okay, we'll just abbreviate. Okay, Mr. Russell's way of abbreviating. Well, the next step would be to divide by this negative 44. And if we divide 88 by 44, negative 44, I think we get x is equal to negative 2. Okay, so the justification for this step, we would say, is the division property. Division property, okay, I'm going to abbreviate again, property of equality. Alright, so then we've done a couple problems, and like I said, the new stuff is coming up with these reasons right here on the side here. You're going to have to, on each step of solving this equation, you need to write down the reason. Yay! Alright, so there you have it. Alright, so here's one last problem. We're asked to solve this formula for A. So what I have is I have R is equal to 0.70 times 220 minus A. Well, what does this formula involve anyways? It says when you exercise, your target heart rate should be between 50% and 70% of your maximum heart rate. Okay, so you don't want to overdo yourself. So your target heart rate R at 70% can be determined by this. Okay, where A is represented by your age. Okay, so in other words, I could figure out what my heart rate should be if I'm 29. Okay, well, I'm not quite 29, but so what we're going to do is solve this equation for A. Well, so it looks like what I have so far, I want to use the distributive property. I want to multiply the number that's out in front here by both of those numbers. Now I'm just going to use my calculator. Let's see here. 0.7 times 220. This first part, I get 154. 0.7 times negative A, that gives me negative 0.7 A. Okay, since I'm solving for A, I really don't care what R is right now. I'm solving for A, so what I'm going to do is move this number to the opposite side of the equal sign. And since I have an equal sign right here, I can start using the properties of equality. Now, by the way, the reason for this step was distributive property. Distributive property. And the reason what we did here is we just simplified that after that. So the next step though I would do is subtract 154. Subtract 154. And I'm doing this on both sides of the equal sign, so the next thing I do is subtraction property of equality. Alright, so this would give me r minus 154. Now, I don't know what r is right now, so that's okay. But what I have now is negative 0.7. Now this negative 0.7, it's being multiplied by a. So the next step, you see, that's what we mean, right? When we write a number next to a letter, it means multiply. So this negative 7 is being multiplied by a. So to get rid of the negative 0.7, I need to divide this side by negative 0.7. And I need to divide this side by negative 0.7. Okay, so the reason why I'm allowed to do this is because first of all I have an equal sign, and there turns out to be a property of equality called the division property. So this is the division property of equality. And once again, we can use my conventions here where we just abbreviate, using the correct symbols and stuff. And so what we'd have is that this would cancel off with that, and so we'd have a is equal to r minus 154 divided by negative 0.7. Now, on this particular problem, please understand, we're not asked necessarily to get a numerical answer for a. We're just asked to solve for a. And so what we do now, well, we would use this equation later on. We'd say, well, what is your heart rate that you want to have? And then we'll find out what the age would be for that particular heart rate. Okay, so that kind of concludes part 1. So we're going to go ahead and move on to part 2 now. And I'll just close this one. So let's see what part 2 is. Alright, so part 2, we're just going to learn a few other ideas, and so we'll move on and learn what the new idea is. Now, we've already worked out several problems already, so I'm going to skip this on the Camtasia video. My regular class will work this out because I'm sure if we did part 1 yesterday, we would have forgotten this already within 1 day. So we'll keep that in mind for the regular class, but for the online class, or we'll just skip this problem. So these are 3 new properties. We have the reflexive property, the symmetric property, and the transitive property. Now, some of these are just like, what? You're kidding me. It's like stupid. I mean, obviously A equals A, okay? And we don't use this property that much in algebra, but it turns out we'll use this property quite a bit for geometry. Like, for example, we might say segment AX is equal to segment AX. And I know that sounds kind of stupid, but that once again would be the reflexive property for segments. If we say angle ABC is congruent to, oh, by the way, we should talk about the measure. The measure of angle ABC is equal to the measure of angle ABC, right? We could do that. So that's in geometry we'd have segments, we also have angles. Anytime you say a segment is equal to itself or an angle is equal to itself, it's called the reflexive property. I know it seems kind of stupid, but actually we're going to see this property several times in geometry. The symmetric property is another kind of stupid one from an algebraic idea. It seems stupid anyways. It says if A is equal to B, then B is equal to A. What? All they're doing is switching them around. I mean, you're allowed, if you have an equal sign, to put it on this side if you want. You can flip it around. So like, for example, let me just write out an example real quick to show you. If we had x is equal to 2, we are allowed to, if we want, to switch it around. We could put the 2 over here as equal to x. Okay? And the reason why we can do that is, well, it's called the symmetric property. And we don't use this property that much in mathematics, like in algebra, but we do use it from time to time in geometry. So let's take a look at what it would look like with the geometry instead. Like if we had the symmetric property, if we wanted to, we could say, I don't know, segment AB is equal to or congruent to this other segment, CD. Okay, well, I'm allowed to, if I want, I can switch, I can flip these. So I can put CD, segment CD is congruent to segment AB. Alright, and so this is also called the symmetric property. It just has to do with segments instead. Now you can do the idea with angles. Angle 1 is congruent to angle 2. And so you're allowed to, if you want, you can flip them around and put angle 2 over here. Angle 2 is congruent to angle 1. Okay? Now, by far the most popular one that's used in geometry is this transitive property. And so let's take a look at that one. This one, from a logical standpoint, should make sense. If A is equal to B and B is equal to C, then A is equal to C. You'll notice anytime you have the transitive property that there's this little chain that's going on. Let me write it out, and I'm going to add a few more sequences to it. Like if we have A is equal to B and B is equal to C and C is equal to D, then we can say, after all that information, we could then say that A is equal to D. Okay, so it's almost like the information is being transferred from one equality sign equation to another one. So the B is like transferred there, and then the C is transferred here. So anyhow, I think the key here is to recognize this. Most people that I've seen that have trouble with the transitive property, they for some reason don't recognize it. So let me just show you some things that I've learned that are helpful. First of all, you're going to see a certain item or a certain variable being used twice. There it is, it's being used twice. Okay? And so that's the first thing I'd say that would give it away that you're using the transitive property. You're using the same variable twice. Now let me just show you what this would look like if we were using segments. We might say segment AB is congruent to segment CD. And then we're told that segment CD is congruent to segment EF. Okay, so you'll notice there's the repeat. Those two are used twice. And so the transitive property says then, oh, well, if we know these two pieces of information, we can then say that segment AB is congruent to EF. And so that would be the transitive property. I always like to draw a little line underneath, but anyhow, based on those two informations, we then go to here. Okay, so now what would it look like if we had angles? Well, same idea. Let's see if we had angles, what would it look like? If we had angle 1 is equal to angle 2, angle 2 is equal to angle 3, then what can you say? You could then say that angle 1 is equal to angle 3. Again, you should recognize the repeat. There's a repeat. Same variables being used twice. So that's the first clue that you have the transitive property right here. So anyhow, we will use that one quite a bit in geometry. And now let's go ahead and look at a few little problems, see if we can do a problem together. Now, so when we do proofs, we want to have statements and reasons. So I'm going to divide this up. This is called a T-bar proof or 2-column proof. And over here we put statements. And over here we put the reason. Okay, so these are just like our algebraic ones, but now we're going to be doing geometry. So what do we have here? We're given this piece of information, AB is equal to CD, and that's indicated by these tick marks. What we're trying to show is that this is the case also. Now, one thing I like to do when I'm trying to do proofs is I try to use some numbers to help me understand what this is saying. So what this is saying is that suppose this is 5, suppose this is 5, and suppose this length right here is 8. Well, what's the total length here then? It would be 5 plus 8, which is 13. And what's the total length over here? It would be 8 plus 5, which is 13. So you can see those two are going to be equal. So okay, now it makes sense to me from a numerical standpoint, and now I just have to figure this out. How do I do this? How do I do this now? And this statements and reasons and stuff. Well, all right, here's some basic guidelines. Typically you start off with the given statement. Okay, so that's what we were given. We started off with that, and we want to end up over here. So my first step I can do is I could write down that statement. AB is equal to CD. And the reason for that was that it was given to me. Okay, so I'm going to write down given over here. Now, you'll notice what I did up here. I took 5 and I started off with 5, and I started off with 5 over here. And what did we do? We added 8, right? We added 8 to this one, and we took 5 and we added 8 to that one. So that's kind of what I want to do down here. Except for I don't want to use the numbers, I want to use segments instead. So with that in mind, what segment did I add? Well, notice what I did. I added a segment. I added this segment right here, and I added it to that one, okay, and I also added it to this one. So what I'm going to do is I'm going to use the addition property. It says I can add things to both sides of an equal sign. So step number 2, I'm going to need a little bit more writing here. I'm going to say AB plus BC is equal to CD plus BC. You see, so I added the same segment on both sides of an equal sign. So step number 2 is going to be addition property. Of equality, right? So we're allowed to do that. Now, back in chapter 1, I learned what this is called. AB is equal to AC, right? If I add these two smaller segments, I'd say it's equal to that one. So step number 3, I'm going to say that AC is equal to the two smaller ones. You see this one right here? It's equal to this one plus this one. So it's equal to AB plus what? Plus BC. Alright. Now at the same time, I'm going to write down this segment, BD. BD is also equal to these two smaller segments. So it's going to be equal to BC plus CD. Okay. Now, since those steps are similar, I'm going to write down the step here for both of them. This is called segment addition. Well, let's write it out. Segment addition. And that was from chapter 1. Okay, so now what do we want to do? Well, I want to rewrite this statement here, right here. However, I want to write it new with some new stuff in it. I want to replace that with something else that's equal to that. And take a look here. I am saying that BAB plus BC, it's actually equal to this over here. So can't I replace this? I'm gonna replace this with something that's equal to. It's equal to AC. Okay. And I want to do the similar trick over here. You see this CD plus BC? It's equal to something also. It's equal to BD. So I'm going to put BD right here. And the reason why we can replace this with this, that's called the substitution property that we learned about. So step number 4 is going to be called the substitution property. And that says, you know, if two things are identical, you can replace it with the other one. So that is what we're trying to do. We're trying to show that right up here. And so let's summarize. What did we do to solve this problem? We started off with the given, okay? We then noticed that they added the same segment twice. Right here, we added BC to AB, and then we added BC to CD. So that's where we had the addition property. Then we realized, hey, how can we say this here? These two segments actually equal AC, and these two segments actually equal BD. And so that's what we ended up with here and here. So this is a little bit tricky at first if you've never seen a proof or never seen this sort of work. It's going to take some practice. And to be quite frank, a lot of students hate this stuff. It's hard for them. I mean, it's going to take a while to think this, but anyhow, let's move on. What we're going to do now is we're going to prove this here. Let's see here. We're going to solve this here. And this is just like the segment addition, but now it's going to be called angle addition. So it's the same idea. We start off with a couple things that are equal. And what we're going to do is we're going to add angle 2 to this one. Okay? And then we're going to add angle 2 to this one. So they started out as equal, and then you add the same thing to both of them. They're still going to be equal. And once again, it's real easy to see with numbers. Like if this were a 30-degree angle, okay, and this one's 30 degrees because it's congruent You know it's congruent because of this symbol right here. And let's say we add on an angle in the middle, 40. Okay. So what's this big angle become? That big angle becomes 70 degrees. Whoops. That becomes 70 degrees. Oh, God. I want to do that. And then this angle over here becomes 70 degrees. Okay? So as you can see, they're still congruent. But now we just have to figure out, well, how are we going to write this out using our two-column thing? I think what I want to do is this. I'm going to erase this. See here. Let's try that capture piece again. Partial. Alright, so there's what I wanted. Okay, so now I have a fresh, clean sheet of paper to do this. So we're going to draw our T-bar here, and over here we're going to have statements. And over here we're going to have reasons. Okay, so when you're doing these proofs or these problems, a good way to start is to start out with your given statement. And we were told, for example, from the diagram that angle 1 is equal to angle 3. So we can start off with that. We can say angle 1 is congruent to angle 3. And that was given to us. And what did we do when I was using the numbers? I added angle 2 to both sides of the equal sign. So I'm going to say what we're basically going to do is take angle 1 and we're going to add angle 2, and we're going to add angle 2 over here. You see? And so the next step we're going to have is angle 1 plus angle 2 is equal to angle 3 plus angle 2. Okay? Now, when we're doing geometry proofs, typically we don't show the algebraic step in the proof itself. So we just leave that part out, and then we come up with the reason over here. We're going to call this, we added the same number, right? We added angle 2 on both sides, so this is the addition property. Property of equality. Okay? Well, now I could replace this angle plus this smaller angle is equal to the bigger angle, right? Well, that bigger angle is called angle DBC. Okay? So I'm going to say angle, well, maybe I should start out with this side over here. EBA. EBA is this one over here. That's this one. Okay, so I'm going to say angle EBA is equal to what? It's equal to these two smaller angles. Okay, so it's equal to angle 2 plus angle 3. Oh, I'm going to call it angle 2 plus angle 3. Okay, so angle 2 plus angle 3. And at the same time, I'm going to do a similar idea. Okay, I'm going to say, what are those two angles added to? And that's called DBC. So I'm going to say angle DBC. Now technically I should use these little m's here because we're talking about measures. So the measure of angle 1 plus the measure of angle 2, measure angle 2 plus the measure of angle 3, and the measure of EBA is equal to the measure of angle 2 plus the measure of angle 3, and the measure of DBC is equal to the measure of which two? Now we're talking about DBC. Well, DBC is this angle over on this side, so it's equal to angle 1. The measure of angle 1 plus the measure of angle 2. Okay, so the reason for both of those statements is the same idea. That's called angle addition property. Angle addition. It's over here for right now. Angle addition property. Okay, so now what we'd like to do is I'd like to do some substitution here. And let's take a look here. Just a little bit here. I wonder if I could replace, if I could somehow replace something. I have angle 1 plus angle 2 here, and I notice it's written right here, you see? So I could, you'll notice they're right there. Okay, so they're both equal, right? They're both equal right there. So can't I replace, I'm going to replace this one. I'm going to replace it with something else that it's equal to. Well, I was told that it's equal to DBC, so I'm going to replace this angle 1 with angle 2. I'm going to write this as angle DBC over here. Okay? Now, there's angles 2 and 3. Now notice, there they are again. They're right there. What can I replace this one? I want to replace this one with something that's equal to. Well, I was told right here that it's equal to this angle right here. So I'm going to replace this one with EBA, see? So I'm going to rewrite this line right here, and I'm going to call that angle EBA. Now, we're actually talking about the measures here, so I'll put the little M in front. The measure of angle DBC is equal to the measure of EBA. Okay, so there we have it. Now, the reason that you can replace this with something that's equal to, well, we found out it's equal to this one, it's called the substitution property. Substitution property. And so there you have it. This was what we're trying to show in that previous problem. We were trying to show whether that was the case, and we did. We kind of showed it. Now, what we've been doing is kind of a geometric proof. We justify our reasons and stuff, and this is going to be kind of difficult at first. If you want, you can review this video over a few times just to make sure you understand how it all works. And hopefully the ideas that we're doing will catch on and you'll be able to do it. Alright, so let's just practice a little bit with the new ideas that we had in this section. If we say angle 6 is equal to 7 and angle 7 is equal to 6, what did they do in this statement here? Didn't they just flip places? Well, if you remember, what's that called? That's called the symmetric property. When you switch places, symmetric property. What happens here? Let's see. Use a different color. If JK is equal to KL and KL is equal to 12, then JK is equal to 12. Well, that was a sequence of stuff. Let me show you again in a vertical way. I think it's easier to see this. We have JK is equal to KL, and then we're saying that KL is equal to 12. Okay? You see, there's your pattern. You'll see it. It's some variable or something's written twice. And then the final step, well, then we could say this one's equal to that one. So JK is equal to 12. And that one comes up a lot. You're going to have to recognize it over and over and over again. You're going to see it often in geometry. And that one's called the transitive property. And then finally, what's this one? The measure of angle W is equal to measure of angle W. That one, if you recall, that one was called the reflexive property. So, much of this section you're going to be doing algebraic type proofs, and you're going to get used to justifying each of your steps along the way. And this is a pretty big section. We covered a lot of stuff today, and that's why in the regular class we took 2 days to do this section. So anyhow, there's our lesson.